Andrew's marvelous presentation. It's hard for me to keep up, but I'm going to try. So I have the privilege of calling myself the representative of Ethereum Foundation, which is perhaps the most exciting thing or a phenomena happening around the world, and probably the most exciting entity that you can come across. So the topic I chose for today's talk is current technological challenges in the development of blockchain, because you would have seen a lot of use cases and everyone talking about how blockchain is going to revolutionize each vertical, each industry, how it is the next generation of database or the next generation of internet. So you know all about the comprehensive effect that blockchain will have on all our lives. But the insider view of what are the challenges that are grappling with the inventor community, and what do we need to do to make blockchain truly mainstream so that it can achieve the vision that it is set out to achieve. So I'm going to focus on a few challenges. Yeah. So the main challenge that everyone is besotted with is scalability. Because without scalability, blockchain can just be a small kind of a technology affecting just a few players, few companies, and not achieving the mass scale that it has the potential to. So what do we mean by scalability? So the most important limit or the constraint is that currently the blockchain can only process about 15 transactions per second. So if you compare it with the 10,000 transactions per second that we would really want it to process for it to really compete with the existing financial services infrastructure. For example, if you take a stock exchange, the latency and the throughput would be millions of transactions. Like the credit card companies would be processing, in milliseconds and so on. So the blockchain needs to be really able to handle those kind of volumes for it to replace the existing infrastructure. And that is not the case. And why is that not a case? Because blockchain is a matrix of nodes everywhere in the world, which are unhackable because each node processes everything that happens in the blockchain. So because each node has to process every single transaction that happens in the blockchain, the bottleneck is the maximum speed of any single node. So the speed of the blockchain cannot exceed the speed of any single node. And how do you overcome this problem? You can only overcome if instead of every node having to process every transaction, you can make the blockchain select a subset of nodes which will process each transaction. So the current thinking is, one concept is the process of sharding, where the network randomly selects a pair of nodes every time there is a transaction to be processed, and therefore releasing the power and the potential of the network, which increases exponentially. So if there are n nodes and only 2 nodes process every single transaction, instead of all the nodes being busy and occupied with the validation of every single transaction, now you're releasing the power which is 2 to the power n, so which is exponential release of capacity. So then it can become truly mass scale, which will be adaptable to existing infrastructure that we see in financial services and elsewhere. So, but everything is not inherently scalable. So this Vitalik told me that there's something called Amdahl's law in mathematics, which says that everything is not scalable. So there are limits to scalability, even if you do all these processes. And there are a few other inventors that have come up with alternatives or stopgap solutions to the problem of scalability. One such remarkable thing is Dr. Sergio Lerner's Lumino transaction compression protocol. It's called LTCP, and he's the founder of a company called RSK, or Rootstock Labs, which releases the capacity of Bitcoin network. And currently with this LTCP protocol, I believe the processing capacity of Bitcoin network goes up to 2000 transactions per second. So those were the scalability challenges, and of course governance is a very big issue in blockchain, which has been occupying especially heads of state and regulators and central banks and so on, not least compounded by the fact that they have very little understanding of the technology itself. So if you are aware, everywhere from Pentagon to World Economic Forum to the most influential governments have set up committees which are focused solely on understanding the technology and how to implement it. So governance is one of them. So we've been seeing a lot of hard forks, which is a controversy, especially in Ethereum, and also compounded by the fact that people do not have an entire understanding of why that happened or how it was solved. So in fact, the way the hard fork was used to resolve whatever issues happened at that time actually should increase the comfort of the users in the technology and in the governance mechanism rather than the other way around, but that's a different topic altogether. And some of the governance issues that we keep facing are, if blockchain is based on the premise that code is law, then at what point do you keep meddling with the code, and how long do you go on, and if you do keep interfering with the code, then who is the ultimate authority? Then does it not boil down to having centralization of some sort? I mean, if you're talking about decentralized platforms, which should be uninterruptible, which should be invulnerable to intervention by anyone, that is conceptually and theoretically against the grain of control or intervention. So if code is law and you keep intervening with that code or law, then what is really legally binding? Then we have to really look at definitions. So if you see a plethora of companies that are doing very successful ICOs these days, you would almost be lured into believing that ICOs or cryptocurrency initial coin offerings are posing a real dramatic threat to the whole industry of venture capital and private equity. So in such a scenario, if an ICO is successful based on a promise that their platform is based on certain conditions, certain initial conditions of supply and certain later subsequent conditions of supply, and how their value is going to be a dynamic function of either the supply or usage and adoption and so on. And later, if something were to happen that were to change it, it's kind of poking in the trust equation between the subscriber and the issuer. So I mean, is it really fair? And what do we do in such scenarios, apart from losing faith and blacklisting those companies, or the market putting down its opinion by way of altering its value of the company? So the next thing is dispute resolution. So there are differing opinions which happen. As you have seen, whenever there is a hard fork that happens, there is a community, either for ideological reasons or because they don't like the founder, or they chance upon this one-time opportunity where they can also claim that they support, another coin which they didn't have to invent. For multiple reasons, hard forks have created unintended alternative coins, and those are also there to stay, and they all make a part of the ecosystem. So we also have to think about what sort of dispute resolution mechanisms are in place. And so every time you issue a new cryptocurrency, these are some of the concerns you have to think about. You have to basically think at the point of creation, you have to think like God, that okay, you're giving life to something, and throughout its life, this is how this organism or mechanism is going to operate. And if something were to happen, this is how it is going to react, and this is how it's going to die, and by so and so age, this is going to be the value, or approximately these are the factors that govern its value. So interoperability and standardization is one of the biggest challenges if blockchain were to be adopted by mainstream. And that is so because blockchain by definition is a relational database. If you have to use something within a company, you don't really need the blockchain because the existing databases solve whatever problems that you have to solve, and they do it pretty efficiently. So using a more cumbersome network only adds to inefficiencies and stuff, and not really doing much. But whenever there are two parties or more that have to interact with each other, either in exchange of information or arriving at a consensus either for a state of the transaction or the value they are holding, or many of the other definitions of money or transactions, then the blockchain comes into play as a very elegant solution for most of the things. So where there are multiple parties interacting, for example, in a foreign remittance situation where a bank has to send the money and the receiving bank has to acknowledge that the money has been added to so-and-so's balance, and the balance update is a different state of transaction with so-and-so change. So there, multiple parties have to agree on the same thing, and therefore the blockchain has to be universally agreed upon. The state transition has to be universally agreed upon. And therefore, that explains the success model of various consortiums, because if you were to use the blockchain for internal purposes and you write a smart contract and nobody else can interpret what you meant when you wrote the smart contract, it is of little use. So if everybody understands and infers the contract definitions and terms as you wrote it, as you interpreted it, then we have a universal use case for anything, whether it's for payments, whether for identity, and so on. So interoperability and standardization is really important. And in fact, in the previous generation, a company called Swift or companies like MasterCard and Visa generated billions of dollars of wealth solely on the premise of standardization and interoperability, right? They just created, Swift, for example, just created a language where the entire telecommunications followed one simple language which all the parties would agree to. And we needed this intermediary to ensure that every party followed the standards that they set. So standardization is really important, and that was the premise on which R3 was really successful. And I brought this up as well when a journalist posed a question to me at the last Blockchain India Summit in December. What do I think is needed for truly making blockchain mainstream? And I said that we need to have interoperability. And of course, Andrew has been brilliant to lead this Enterprise Ethereum Alliance, which is putting to shame every other alliance that is in place. Even I was thinking of having a blockchain council India, but then we have a global Enterprise Ethereum Alliance where every single big corporate and every single small inventor worth his name is joining the alliance, and that's what we want. So of course, working together in this alliance will be a big challenge, which I'm sure people will figure out. So threat of quantum computing. So how many of you are aware that for the first time in February 2017, something we thought was unbreakable or invulnerable, which was the SHA-1, which was one of the key elements of cryptographic science, was broken, and it was done by a couple of parties. I think one had something to do with a university in USA, probably MIT or something. And once it was broken, it automatically leads you to question what is the insularity of the current blockchain protocol. So you know that the current blockchain technology is based on SHA-256, and if that were to be broken, for example, by quantum computing and nano computing and so on, then probably we have to invent something else to ensure that the cryptography behind this technology is secure. Because then if quantum computing is able to break SHA-256, then none of these that we've talked about, like zero knowledge proofs, or I'm going to go into more technical solutions of scalability and privacy, none of those would hold true. So then we'll have to come up with a more advanced and more superior technology. But that's in the nature of evolution. So something that we invented in the past century is no longer relevant and no longer applicable to the current problems, and no longer solving the purposes of the real world. So we have moved on to various superior technologies, which is in the nature of evolution, which will happen with this as well. So current challenges of DLT: Ethereum currently takes 14 seconds to confirm a transaction, and this is not really fast enough if you want to implement Ethereum for retail payments or IoT, where there are millions of devices sending data to the blockchain, and the blockchain has to process these transactions and return it. User interface security: there are two kinds of issues. One is with the loss of the key itself, which nobody can help, because if you recover passwords and things like that, if you lose passwords, you have mechanisms to recover them, but if you lose a key for an asset like Bitcoin, then you've lost the asset itself. So most of the sensational stuff that you heard, like the Bitfinex hack and the Silk Road and those things where people lost a lot of life savings which they invested in Bitcoin, had to do with the security in keeping the keys secure. It was nothing to do with the protocol being hacked. So it was to do with siloed institutions like exchanges, for example, which were entrusted with the task of keeping the keys secure, and they failed in their task. So unfairly, or you know, in the nature of things, that's how it happens. Unfairly, this got rubbed off on the whole Bitcoin and blockchain itself, that probably the technology is not safe. But that is not the case. So then we have some real problems which are making the likes of Vitalik lose sleep, and those are crypto economic problems, something like nothing at stake problem. So in a blockchain, there is a miner or there is a node that has to send transactions, and you have to all assume that the node behaves honestly. And what if a majority of nodes are dishonest and they try to, so the blockchain is essentially solving the double spend problem. And what if the nodes are dishonest and they are always trying to double spend, and there's no penalty for that behavior, right? So yesterday, unfortunately, at the hackathon, our handsome Australian's wallet got stolen while we were outside. So when we assume that, you know, the Indian Institute of Technology, people who come here are like intellectually superior and they would not do such things, but we could have similar cases in blockchain too, where there are some dishonest nodes who are continuously trying to do this double spending, and if they have nothing at stake, I think the human nature is such that you're tempted to cheat. So you have to introduce some game theory kind of principles where there is a penalty for behavior which is undesirable, and there is even more penalty for recurring behavior of such type. So there is something called slashing conditions, where players are required to put in a deposit, and the they forego the deposit if they are proved to be acting dishonestly. And because it's blockchain where it is transparent, you can mathematically have equations which prove that a node has acted dishonestly. So those sort of solutions are being worked upon. And then there is energy efficiency, of course, where, as you know, most of the mining happens in China, as well as the trading and volume of transactions in Bitcoin happens in China, and that has come to be so because of China's competitive advantage in producing electricity really cheap. So the Bitcoin mining has come up in areas where electricity is rather cheap, and it is quite energy intensive, and that is so because the proof of work requires that you actually do work to prove that you can validate a transaction. And if there were a superior solution to this, where you don't have to actually expend work, but you can reliably prove that you can validate the transaction, which is the current transition that is being conceptualized to proof of stake. And if proof of stake could be proven to be fail-safe, that actually just with the proportion of stake, if you are able to validate the transactions, again, you would be tempted to cheat, but if there were a system where you could not cheat, even though it's just stake and not work, then it could replace much more elegantly and more efficiently than the current proof of work. So this is an economically, provably more secure algorithm or more secure state of things for blockchain, and therefore we are actually aiming at that. And of course, as in everything, you have to, you must have come across when you were coding yesterday, you have to make a trade-off between programmability and privacy. So if you want to have maximum privacy, then you have to compromise on programmability, which is what the Bitcoin protocol was. So Satoshi really wanted to make it safe, and this is what I said to the journalist who misquoted me from Mumbai Mirror. I told him that Satoshi really wanted it to be so safe, so he made it a closed kind of mechanism like Apple, that not too many features, there was not so much flexibility to build too many varied features on top of Bitcoin. But Ethereum is an open source thing with a lot of flexibility to build anything. You can build any logic that can be represented as logic into an algorithm, and because it is Turing complete, Ethereum can actually process it as a computer. So anything, any transaction or any concept that can be represented as logic or as computer code can be processed in computational terms by Ethereum. So it is much more general purpose. So Ethereum is like a computer, and now like a decentralized world computer, rather than a simple tool like a device trying to calculate something. You know, whether it is a thermometer, whether it is a calculator, whether it is a barometer measuring pressure or something. But here is a world computer that can compute anything that is computable. So that's the difference between Bitcoin and Ethereum, and which is perhaps the reason why Ethereum has been meteorically rising in the past few months. So some of the reasons behind Ethereum's magnificent success are that it is trying to be truly general purpose, and it was always meant to be general purpose, and not specifically focusing on any particular niche use case or any particular target segment or geography or stakeholder. It is meant to be truly general purpose, serving stakeholders across the spectrum, and meant to be even for applications that you haven't imagined today. It is meant to be for future as well, whatever you could come up with. So there are a few updates to Ethereum that we are expecting. One is called, okay. I'm looking very ugly, I know. In the, okay. Okay, from far. Okay, I need to step back. All right. So there are a few updates to the protocol that we're expecting. Some of them are called Metropolis, EIP 86 and 96, and Vitalik will talk more about it when you meet him at the summit. And privacy, Ethereum is, to its credit, Ethereum is in discussions with Zcash, because they are the inventors of zero knowledge proofs and ZK snarks. ZK snarks are zero knowledge, non-interactive arguments of knowledge, and Ethereum is trying to integrate ZK snarks on top of the protocol so that you can build privacy on some layers. So at the base layer, you will have, you know, the traditional base layer, and you can have another layer on top, which would be really private, so that transparency is not compromised at the base layer. But if you want further privacy, then you can have ZK snarks integrated for some applications, for example, like blind voting, voting or blind auctions and those kind of things, where one player would not know what the other player has bid, or one candidate would not know what the other player has voted for, and things like that. So Since privacy is one of the key preoccupations of the inventors of blockchain, there are quite a few solutions. Most of them are low-tech solutions, and I'm going to touch upon some of them. So there are a few low-tech solutions. One of them is one-time use payment addresses. So let's say Andrew is sending me money all the time. So instead of the blockchain reflecting that Andrew has sent, $500,000 to Arifa, Andrew has sent again a few $100,000 to Arifa, and so on. The recipient and the sender's addresses are made opaque, and only the transaction is apparent. And of course, even this is vulnerable to transaction graph analysis, and you can also do a pattern reading to know that X is sending so many transactions to Y all the time, and you can ultimately interpret who that X is or Y is, but at least in the interim you can mask the identities of the senders and the receivers. So there's this other technology called mixing and tumbling, and there are current services called Bitcoin Fog, BitMixes, CoinJoin, CoinShuffle, and so on, where you mix all the transactions together so that the sender cannot be identified directly with the receiver. So all the senders are on one side, the transactions in the middle are tumbled, all the receivers are on the other side. So you're not able to identify a single transaction's route saying it is going from X to Y. You know that it could be from ABCDE and it is going to XYZ. So you don't know exactly that A can be traced to X. So this has some problems, and this is a real problem for the regulators, because they want KYC, they want anti-money laundering things, and they want perfect traceability, where every time a $0.01 dollar has left one account and goes to the other account, they want to be able to capture it. They want to be the big brother watching over everything that happens. So they have a natural disinclination towards technologies that disrupt the status quo. So some of the other low-tech solutions restrict read access to the blockchain, but it is not suitable where participants want to keep privacy of their transactions. And if the blockchain is leaked, then it no longer is anonymous. People can figure out that this transaction has happened between so and so. And then there are side channels and payment channels, where not every transaction has to be processed on the blockchain. Some of them can be processed on a side chain which hangs off the blockchain, and which can increase dramatically the efficiency, because all these smaller transactions can happen off chain, and after, let's say, 100 transactions or so, you can update the balances, which can happen on the main blockchain. So therefore, you're not blocking the processing speed of the main blockchain. You're just updating in the subset of side chains whatever happens between the two major transactions. And then there is the other solution of storing sensitive information off-chain, but this again violates the basic definition of blockchain, that being a single source of truth, that being decentralized, and so on. Because if you want to store it elsewhere, somebody or some entity has to do that, which amounts to centralization. And what if that person meddles with that? So even with Zcash, these kind of questions have come up, that are they truly anonymous, or Zcash actually holds the data somewhere, which is a valid question to have. So now coming to some high-tech solutions, which are what are exciting the intellectual thought leaders in this space, and these are 4: stealth addresses, Pedersen commitments with range proofs, ring signatures, and ZK snarks. So stealth addresses. So here, a sender uses the public key of the receiver and creates an address. So what happens is, the recipient, he does not know which transaction pertains to him, so he has to decrypt all the transactions in the space, and then he has to match it with the key sent by the sender to figure out which transaction is his. So there is certain inefficiency in the process, because the receiver has to decrypt all the transactions rather than just receiving one transaction and not having to bother about figuring out anything else. So this was initially invented in dark wallet as an add-on to the Bitcoin protocol. And this also uses a technology called elliptic curve Diffie-Hellman exchange. Then there is Pedersen commitments. So there is something called homomorphic additivity in Pedersen commitments. So basically what you do is, instead of making public an entire transaction, you just commit to it by committing a portion of the transaction. So instead of publishing the entire transaction, you've just committed to the transaction by taking a subset of it and creating a hash of it, so that nobody can backtrack the entire transaction, they just know the hash. And if you want to make it more complex to decipher, you can also add what is called a blinding factor, which is basically irrelevant noise you add to the signal, so that it becomes less easy for somebody to figure out. So when you do this, when you add the blinding factor and you create the hash, you share this with your recipient, and the publisher can later say this was the blinding factor. So therefore the recipient can work backwards what the data was. So the entire data is not published, but you just know that the subset of the data pertains to so and so hash, and that hash was figured out by the recipient. So this works on the principle of homomorphic additivity, and this was initially invented by Greg Maxwell. And then there is ring signatures, which is an interesting concept. So you have a ring of sets. So something is created by a set of keys, not all of them. So you can prove cryptographically that a set of keys was used to produce a transaction, but you don't know which keys. So imagine a plate or a ring with a lot of keys, and each transaction was only created by a set of those keys, and you don't know which two out of 12 or X number of keys, you don't know which two created this transaction. And then you send the transaction. So the recipient only knows that you can prove that the keys that were used for this transaction came from this particular ring. So it's a kind of mechanism where you know that keys belonging to a particular ring have initiated this transaction, and that is enough for you to know that the transaction is valid, but you don't know exactly which specific keys have been used. So this is called ring signatures, and this was used in CryptoNote protocol. And then the final most exciting high-tech privacy technology, which everybody is drooling over, and that's zero knowledge proofs. And this was done by a company called Zcash, and the concept is that instead of having to reveal the entire information, there is a mathematical proof which you can follow to prove that you either have that information or a condition is true without having to reveal the details. For example, let's say there is a courier I'm sending to somebody. In order to prove that in the current circumstances, I have to say that Arifa sent a courier to so and so, and the courier had these elements, these items. The courier contained these items. Then I'm revealing everything, right? I'm revealing who I was sending it to and what it had. And if there was a zero knowledge proof where, without having to reveal that I sent X items in the courier or to whom I sent, I could just prove that the courier was sent, and irrefutably, then it serves a lot of purposes in blockchain. So this invention of ZK, SNARKs, and zero knowledge proofs has made the application, real world application of blockchain phenomenally exponential. So you can now actually apply the cryptographic principles and the blockchain to a lot of concepts because of the advent of zero knowledge proofs. So this is just some Indian companies and what they're doing. Vitalik's observation from his first trip to India was that he was excited to meet the community, and he noticed that the community was still rudimentary, in the sense the community was working on concepts and technologies like exchanges and related to Bitcoin, or to do with cryptocurrency as a storage of value or as a token of digital asset. And the community was not really looking at advanced applications like we are seeing in the Western world. But now I think you would be surprised from the outcome of our hackathon, because we saw quite a few imaginative applications, and we were also pleased to see that they didn't restrict themselves to financial services use cases, but they touched upon real world problems which were specific to India, which were indigenous to India, which was really heartening to see, because one of the challenges that I chose was the agriculture and farming, where if there was a way for us to give the maximum value of the supply chain to the producer, to the farmer, instead of it going to the intermediaries, then we could prevent a lot of farmer suicides. Like, they are the real annadatas, right? So they are creating, you know, everything that is required for our sustenance. And how ironic and how inhumane is it that our annadatas are dying because they don't see a light of hope, and they don't see anybody championing their cause. So if blockchain or a technology like this could solve real world problems like those, where you reapportion the stake that was going to the intermediaries back to the real creators who are really deserving and probably suffering in the current state of affairs, then you would have really applied blockchain to life-changing and world-changing phenomena. And that is what the initial original vision of this whole technology was. So Satoshi Nakamoto was not inventing Bitcoin for him to be able to surreptitiously send some coins or some currency to somebody anonymously. He was inventing it as an intellectual protest to what's going on in the system. And as you're all aware, we had one unfortunate incident where our Prime Minister brought upon demonetization, and a lot of intellectuals actually thought it glamorous to support this because they were least affected. And that's not the stance to take, because we also have to care about how it affected the stakeholders who don't have an identity, or at least who don't have a listed identity. So here is where blockchain's potential to solve these problems is phenomenal. And with our support, with us embracing and leading the way for the naysayers, I think there's a lot of revolution that is ahead of us. With that, thank you so much.